Hello and welcome to a new series of Horizons. We're on a voyage of discovery to the four corners of the globe. We're looking at cutting-edge science and technology which has the potential to shake up our lives, our homes, the world in the decades ahead. I'll be talking to some of the world's most influential opinion formers, from chief executives and entrepreneurs to scientists and academics. And together with a team of reporters from across the world, we'll be discussing some of the big issues of the day. We'll be talking to the people most affected by them and investigating the technologies which have the potential to change the world. So welcome to Horizons. By taking humans to some very inhospitable places, like outer space, the space industry is developing some incredible technologies which are helping cutting-edge developments here on Earth. Air travel isn't the only area of transportation where NASA expertise could play a radical role in the future. But in this case, its adoption could take a lot more than small tweaks to change the way we move around. Forget buses. In the future, our commute could look quite different. Here at the Ames Research Centre, they are developing a new kind of transport infrastructure called SkyTran. Think driverless elevated pods that are controlled by software designed by NASA to control robots in space.
Imagine a city where you didn't have cars everywhere. Imagine there's cities where you could walk across the street and you didn't have to worry about being run over. This is what people want, is livable cities.
SkyTran is a lightweight, high-speed, urban personal rapid transit concept designed around a network of elevated guideways and computer-controlled, magnetically levitated pods.
It's a car and it's a train at the same time.
The two-person pods are automatically routed over the network to provide unscheduled, on-demand, driverless public transport that takes people directly to their destinations without stopping.
It's unlike a train that stops at every station, right? SkyTran doesn't stop at every station. It has an offline berth, kind of like a freeway.
The idea of personal rapid transit has been around since the 50s, and numerous systems have been trialled. SkyTran believes what makes them different is a combination of magnetic levitation technology and elevated guideways, which require less infrastructure than conventional PRT systems. So am I right in saying that all of the technology and the science behind this system is actually not in itself particularly novel? It's well-proven technology that's been around in other forms for a long time.
Well, the maglev is different. So ours uses a passive form of levitation.
And what does that mean?
That means there's no power used to levitate the vehicle.
In traditional maglev systems, an electrical charge is passed through coils in the track to create levitation. But this design only requires an initial burst of energy for uplift.
Think about an airplane. An airplane doesn't fly if it's sitting on the ground. Similarly, SkyTran doesn't fly if it's stationary. You have to have at least 10 to 15 miles an hour forward speed before it takes off.
So an aircraft wing is changing its attitude to encourage airflow.
Right.
But you're doing the same mechanical thing, but not messing around with airflow, but messing around with magnetic fields there to encourage the uplift.
Exactly.
And no one else has done that?
No one else has done it.
To achieve lift, a motor in the rail provides a burst of energy to propel the vehicle forward. As it accelerates, the wing tilts, creating drag. The sustained movement generates its own magnetic field, lifting the pod around a centimetre off the track.
The center tube is for propulsion, and that gets power from the guideway. So there's a wiper system just like on a train. It's a kind of a new way of doing a motor. Right. And I can't say more than that, unfortunately. I'll get in trouble.
Okay. Very mysterious.
Very mysterious.
Okay. While the maglev technology is innovative, what is really radical is what SkyTran would cost to build.
Let's say a typical city puts in a 10-mile light rail system. They would spend between $500 million and $1 billion. So that's $100 million per mile.
And your system would cost what per mile?
Below $10 million. So
less than a tenth of the traditional cost. The automated control system is operated by software NASA is helping to develop based on the same design principles used for its Mars rover mission.
Computerized transportation wasn't really possible 20 years ago. So it's an advance in computer technology.
The computer technology bit is the bit that says, I want to go to Maida Vale Road down there, and it takes me there.
Yeah, and if there's two lanes of traffic coming together, it merges the vehicles without collision.
Right.
You know, humans are terrible at driving cars. Computers are actually would be much safer to operate personal vehicles.
The team here are already in discussions with a nearby city which hopes to be the first to test the system to ease its congestion.
We've been talking to the city of Mountain View for quite a while.
Which is here.
Which is right here, our next door neighbor. They have a huge traffic problem because there's about 5 Silicon Valley companies in Mountain View. Yeah. And if they keep hiring the way they're hiring, well, it'll be getting worse.
While the system is currently still at the prototype stage, NASA has already earmarked a site here at Ames to build a quarter-mile-long test loop, which SkyTran hope will help them move the concept out of the laboratory and change our attitudes to personal mobility. How significant do you think this technology, this approach to transport, could be in the decades ahead for us?
My generation loved to drive, and we saw the car as a sense of freedom. I think the 20-something crowds now see cars as a limitation. They don't want to drive. They want to be on their laptops. So I think this is a generational thing, and it's the future of transportation. Sometime in the not-too-distant future, commuters could well be heading into the city centre in curious-looking driverless shuttle pods like this. The technology to do that is already here. The problem is we already have a personalised mass transport system. It's called the car. Getting people out of their cars and into structures like this, that could well be the issue.
By inspiring people, we're inspiring them to take on difficult challenges that lead to new businesses. It gives us a reason to be doing some of the science and technology that we do. It also inspires the next generation of scientists and technologists who may want to take on space, but they might take on totally different problems as well. So it's always been the case that this kind of exploration turns people on and inspires them for the future. And I look forward to that continuing.
Booster ignition, and shuttle has cleared the tower.
If space exploration in the 21st century is to be as exciting as it was when we first landed on the moon, it will also have to encourage exploration here on Earth.